One last time, not on the quiz tomorrow. And if you looked on the assignment sheet, this homework's due on Monday to give you the opportunity to study for tomorrow's quiz. All right, so this homework tonight is due on Monday and not on the quiz. All right, I need a little help from you. A couple units ago, might have been last unit, I think, we went over a fact about the exterior angle of a triangle. In this case, DCA, this exterior angle. Anybody remember how I could find it? Let's go, Dylan, let's roll. So name them in my diagram. So angle, and what do I do to them? Add them up. Yep. Anybody remember the names? It's already on your paper, but the names of those, what do you got, Mason? Remote interior angles. Yep. We all remember that fact. Yes, no? We remember that one? Remote interiors. I'm going to take that next level right now. If that exterior angle is equal to the two remotes added up, do you agree with this statement? That the exterior angle has to be bigger than both of these separately. If they add up to DCA, that must mean DCA is bigger than angle A by itself, and angle DCA is bigger than angle B by itself. We agree with that? That's what I'm going to show you today. That's half of today anyway. All right, is that ready? And any exterior angle is bigger than its, what are these called again? Remote interior angles. Okay, so any exterior angle is always bigger than either two remote interiors. All right. So here's what I'd like you to do right now. And I'm sorry you're not working in groups to bounce ideas off each other. In my diagram here, I would like you to find 5 angles if you could. As many as you can, but there's 5. 5 angles that are less than angle 7. Before you start, let me give you a little tip. Angle 7 is what type of angle? Oh, no. It's exterior. It's exterior for this triangle, MKL, and name another triangle it's an exterior angle for. Go ahead, Anthony. JKL, yep. All right, so if you could, find as many as you can, and then hopefully as a class, we can get 5 of them. That's the goal. Let's get 5 angles that are less than angle 7. If you can't get 5 individually, that's not a big deal. But as a class, I think we can do it. So what you guys are trying to find are some remote interior angles to angle 7. Can you find any angles that are remote interior for angle 7? And we already looked at 2 triangles already. If you come up with 1, that's fine. If you come up with 2, great. At least come up with 1 of them. All right, here we go. What's 1 angle you have for me? 1 angle only. Let's go. Here we go. 23. Name an angle you have that you think is less than 7. Angle 3. I like it. Here's why. If you didn't have angle 3, obviously write it down. If you don't know why angle 3, take a look. We said angle 7 was an exterior angle for this triangle, right? Is it angle 3 a remote interior to it? We're good there. All right, perfect. Name another angle. And if you don't have one, that's fine. I'll go on to somebody else. 28. Angle 4. I like it. Okay, why angle 4, everybody? Angle 7 is an exterior angle for that triangle, and 4 is a remote interior for it. All good. Okay, anybody got any others here? 2 out of 5. 12? Well, I'm listening. Okay, well, that's not a reason I'm going to accept. It is actually correct. That was actually one of the last ones is angle 2, but not because it looks like it. I'll get to at the end why. All right, I need somebody to tell me another angle. Angle 7's less than before I get to angle 2. All right, but it is correct. 4. Angle 6. Okay, I can't say angle 6. Don't tell me because it looks like it either. These are linear pairs, everyone, right? I have no idea which one's bigger. All I know is the exterior angle is bigger than the remote interiors. That's it. I do not know if it's bigger or smaller than the linear pair. Everyone good there? Classic mistake. We're good? All right. Any other angles here? Any other angles? Any other angles? 7? 5. Good job. Angle 5. Because it's remote interior with angle 7 in this triangle right here. And I'm looking for one more, here's a hint. You can't name it by a number. Can't name it by a number. Hopefully that's a hint for some of you. You got it. 28. Angle LKJ. Good job, everybody. Again, that's a remote interior angle with angle 7. Now, let me get to why angle 2 is now correct, other than it looks like it. What did we just say? Angle 7 was bigger than LKJ, right? How's LKJ made up? 2 and 4. So if 7's bigger than the whole angle, shouldn't 7 be bigger than its parts? And that's why angle 2 is smaller. All right? Questions? All right, another challenge for you. Same diagram. Can you find me any angles that are greater than 6? Greater than 6, and there's 2 of them. Greater than 6. We know 7's not one, right? Can't say the supplementary one is. All right, find angles greater than 6. So can you find an exterior angle where 6 is a remote interior? All right, can you find any exterior angles where 6 would be a remote interior? Okay, let's see. Even if you got just one of them for me, that's fine. An angle bigger than 6. So hopefully you're giving me an exterior angle to this triangle where 6 is in there. All right, hopefully you're giving me an exterior, not 7. Here you go, 2. Angle 8. I like it. Angle 8 works. Take a look, everyone. Why angle 8? It's exterior. Did I draw that right? Oh, sorry, this one. I should have went bigger one. Should have went with the bigger one. Angle 8's an exterior angle for the bigger triangle, JKL, where 6 is remote interior. And there's one more. This one's a little tougher to find out. Hopefully somebody found it. 29. Yeah, got it. Everyone, why angle 1? New triangle now. New triangle. Everyone see angle 1? Isn't that exterior to this triangle? Even though it's inside one, doesn't matter. It's exterior, and 6 is the remote interior. Nice job, everyone. Questions? All right, I'm going to do this next one with you instead of on your own because this is a toughie on this one. Okay, in this triangle, ABD, AB congruent to BC. Mark it. AB congruent to BC. From last unit, you should be able to mark your diagram with something else now. This I will ask you to do. If you know those 2 sides are congruent, there should be something else you can mark on your diagram on your own now. What else can you mark on your diagram if those 2 sides are equal? 21? Why, Jack? Because Not only the sides congruent, but nice angles across. Perfect. And we're supposed to determine one of them's true here. Which angle's bigger than another one, right? Do you see any exterior angles up here? You have two triangles in there, ABC, BCD. Does anybody see any exterior angles for any of them? What do you see, Sam? Three's exterior. Remember, exterior is when I just continue on a side of one of the triangles. If I went up here, then this angle would be exterior. I wouldn't consider 3 exterior, though. BCD, this one right here? Yeah, you got it. And also, could I say the one next to it? Everyone agrees this one's an exterior angle for ABC, and this angle I marked in green here is an exterior angle for BCD. Everyone agree? Let's focus on, Sam, you're correct right here. I'm just going to focus on this one, BCA. Somebody tell me an angle that BCA is greater than. Go ahead, Julie. Angle 4. And somebody else. There's another angle that's bigger than. Angle 4 and angle, what do you got? Angle 3. Everyone agrees? Because it's exterior. We're all in agreement. What did we mark BCA congruent to? What did Jack tell us it was congruent to? Angle BCA is congruent to angle. So everywhere I see BCA, what can I put in? So angle 1 is also bigger than 4, and angle 1 is also bigger than 3. And I think that's one of my choices up there. All right, 1 bigger than 4. A little tougher. Are we okay on this exterior angle fact? Because I'm going to go to a second and final fact for today. Exterior angle bigger than the 2 remote interiors. All right. Next fact you're going to find on your own. Okay. Everyone seeing the 2 triangles, I have a missing angle. First thing I'd like you to do is find the missing angle in each of them. So go ahead, find the missing angle in each of them. Nothing crazy. We know what all the angles add up to. $42 and $35. I'm going to give you about 2 minutes. What I want you to try to do is see if there's any relationship pattern between the sides and the angles of both those triangles. And if you feel comfortable, turn to the person to your left, right, and back of you and see if they can find anything as well. All right, because this may take more than one person to do. All right, so I want you to look at both triangles, look at the angles and the sides, and see if you can see any pattern or relationship between the sides and the angles. All right. If you can, you can't, turn to somebody to your right or left, in back of you, in front of you, and see if they see anything. And don't feel bad. It's tough. All right, let's go back now. Right or wrong, I have respect for you for taking a chance. Anybody think they see a pattern at all? What do we got? You got me there. Not what I was looking for, but you got me. I could have changed multiples of 5. 19's not a multiple of 5. Okay. Got me there, I guess. Okay. Relating to the sides. Go ahead, Dylan. Sorry, Emma.
I said that the longer the side is, the smaller the angles are that it holds. Like on the.
We're getting there. We're getting there. We're getting there. Emma, you want to take it to the next level here? We're getting there. You guys are almost here. You're almost there. We're almost there. We're almost there. Now, what do you got for me? Okay, we're almost there. You're there. You're there. Okay, we're almost there. That's not what I'm looking. We're almost there. That might be true, but I'm almost there. Okay, ready, everybody? Let me just try to. You guys are all correct. Let me try to tie this together. Look at the first triangle. What is the biggest angle in the first triangle? 82. What is the biggest side? Ready? What is the smallest angle in that triangle? What's the smallest side? Where are they located? Across from each other. You were there. I told you were there. Yeah, you were there. All right. In any triangle, the biggest side is always located across from the biggest angle, and the smallest side is always located across from the smallest angle. Okay? All right, so let's write that down. So in a triangle, biggest side is across from the biggest angle. And I had a number 2 in there, and I was going to write in smallest side across from smallest angle, but I got yelled at by my geometry classes yesterday. That's the same thing. So fine, I'll leave it blank. If your OCD is kicking in like mine, because I can't leave things blank, I'd write in a triangle, smallest side is across from smallest angle. All right? Which it is kicking in right now. So yes, you are correct that the biggest angle surrounds the 2 smaller sides, because what's across from it? The biggest side. So the other 2 have to be the smaller sides. Okay? All right, let's put this to use before we call it a day. Go right ahead, everybody. Angle problem 1 and 2. Please read the directions carefully. I'm looking for you guys sides from shortest to longest for me. Shortest to longest. And I see many of you going to your calculator. Good, because you need to know all 3 angles before you organize them. Okay, while you guys are working, I'm going to ask a couple people questions here. Here we go. Number 20, what'd you find for your missing angle B? 92. So what was the shortest side then? BC, because it's across from the smallest angle. Next side? BA. And what's your largest side? AC. Nice job, the one across from 92. Perfect. And how about number 2? What are my missing angles for number 2? My missing angles. Here you go, 26. What are my missing angles? 73, 32. Nice job. All right, somebody give me the smallest side now. Smallest side, what do you got? 28, smallest side? SR. Followed by ST, and the largest side across from 75, RT. Too bad to find that one. All right. Go ahead, read through that second to last one there about triangle ABC. Some of you might want to do this, but you cannot answer this question just by looking at this. What do you know about angle A, B, and C if they're 3 angles in a triangle? They add up to 180. I need to figure out the value of x, and then I need your help to plug it back in to find these angle measures. All right, so I have 3x, I have 4x minus 19, and I have 3x minus 1. All of them add up to 180 degrees in a triangle. So I'll give you guys a second or two. Go ahead and figure out x. And then if you're feeling crazy, go ahead and plug it back in to figure out the angle measures. When you're ready, I just need the value of x. Number 26, value of x, 20. Nice job. All right, everyone take 20, plug it back in now. Take 20 and plug it back in. Here you go, 2, ready to roll here. What's angle A if x is 20? 60. Keep going along here with me. Plug in x for angle B. 61, and for angle C. All right, everyone. So I got 60, 61, and 59. Let me know, why is it not isosceles? I need 2 angles, and all 3 of them are different. Tell me why the triangle's not obtuse. No angle is bigger than 90 degrees. So now let's determine which one's the longest side. Well, which one's the biggest angle up there? 61, which is angle B, so that must mean the side across, which would be AC, is the longest side. And if you can't visualize that, draw it out. Triangle ABC. And you'll see that AC is across from angle B. All right. Nice little problem. Questions? This is going to be a tough one coming up. This is how I'm going to end it with this above average group here. And I'm going to make it even tougher. I need you to please cross off longest, the shortest. The shortest. And this is in the entire figure. Not each triangle, the entire figure. I need your help finding the shortest side. I see many of you guys going to the calculator. Yeah, you're going to have to find the other missing angles for me before I can find out the shortest side. Yep. Absolutely. All right, what's my missing angle for BD? Angle BDA, that missing angle? 60? 60?
Yeah.
And how about the missing angle CBD? 57. All right, let's talk now. Because it's ready? This is not as easy as, and this is why most of you would do. What's the smallest angle up there? 53. What's across from it? BD, done with the problem. No. We're not done. Here's why we're not done. Yeah, hey, yeah. BD is the smallest side in that triangle. But what do you notice about in triangle ABD? Is BD the smallest side in that one? No, it's actually the longest one, right? So there's got to be something smaller than it. So how are we going to figure out if it's not BD, what's it going to be? Here's what I like you to do in these type of problems when I give you two different triangles in the figure. Take each triangle, so triangle ABD, and triangle, what's the other one, BCD? And I'll give you 30 seconds right now. On your own, in those two triangles, list the sides from shortest to longest for me. In each triangle, list the sides from shortest to longest. And then we'll figure out overall what's the shortest side. All right, I need help from two people. Let's start with number 15. Can you list the sides in ABD for me? Yep. And can I have someone list the sides in BCD for me? BCD, what do you got? 16. We're all good. We're looking for the shortest side. So really, what's the shortest side in each of them? ADN. So it's going to be a battle between those two. All right, it's either going to be DB or AD. Now again, why can it not be DB? Look at what you just wrote here for triangle ABD, everybody. Why can it not be DB being the shortest side? Because how many sides over here? How many sides are shorter than it? Two other sides are shorter than it over here. Everyone see that? So it can't be DB because there's two other sides shorter. And out of AB and AD, which one's the shorter side? AD. So it's got to be AD. We all good there? Okay, can't be DB because there's two shorter sides. Grab a Chromebook, grab a textbook, get going on this homework due on Monday again. I'll be after school today if you guys want to come by and review any of the points of concurrency.